Alright, my name is Kenny and we are going to be doing 3.1, the nature of exponential growth. What is exponential growth? Exponential growth is a pattern of growth in which each term is multiplied by a constant amount, which is greater than 1 to produce the next term. So here's the standard equation for exponential function. It is fx is equal to ab to the power of x. And you know it's an exponential function because the exponent is a variable, and the exponent is a variable because that is what we are usually going to be subbing in terms for. So let's do our first application of exponential growth. Okay, the first question is, a bacterial colony has an initial population of 32. The population doubles every half hour. So first off, we're going to write an equation that relates to the population P to time T measured in 30-minute intervals. So first, the equation is going to be PT is equal to 32, which is our initial population, bracket 2, because it doubles every half hour, and we're going to put T over 30. 30 is representing half hour. Okay. So next we're going to have to sketch a graph of this relationship for 2 hours. So we're going to make our graph here. And down here we're going to go by 60 minutes. So 60, 120, 180, and 240. And this is our time in minutes. Okay, and at the side we're gonna do population going up by 100. So 100, then 200, then 300, and then 400, which is our population. So I made a chart here. P stands for the population and T stands for time. So at 0, which is the original time, which is the original initial, the population is 32. At 60 minutes, it's on 128. At 120 minutes, it's 512. And at 240 minutes, it's at 2048. Now, time to graph this. So at 0, 12, so all the way up here. And time to connect this. Put an arrow so it goes on. That is how you graph an exponential function. Okay, so we have to use the graph to determine the approximate population after 1 hour. So using the graph after 1 hour, we know that it's 128. So our original equation is PT equals 32 bracket 2T over 30. Okay. So we're solving for 1 hour. So P 1 hour equals 32 to 60 over 30. So then it becomes 128, which is the population after 1 hour, equals to 32 bracket 2 squared, because 60 over 30 is squared. And when you plug this into the calculator, you get 128 as your population. Okay, here's another question. So, the dog population tripled every single day. On the first day, the population was 100. What is the population after 4 days? So over here, I made a chart. D stands for days, and P stands for population. So the initial is 100. On day 1, it triples, so it goes to 300. On day 2, 300 is tripled, is 900. On day 3, 900 tripled is 2700. And on the 4th day, 2700 is tripled to 8100. Okay, here's the equation. P population equals 100 bracket 3D, because we're finding the day. Here's the graph I made. So the bottom here is the day, and over here is the population. And as you can see, 0 is at 100, 1 is at 300, 2 is at 900, and 3 is at 2,700 all the way up here. So here is showing the differences between each population. So on day 0 to 1, which is right here, 200 is the difference between 300 and 100.
And today I will be teaching you guys how to do 3.2, and in 3.2 we will be learning how to do exponential decay, and also connecting to negative exponents. So for example, some of the questions are like this right here, and these are some of the small questions that we will be learning. And yeah, okay, so let's start off with the first question. It's an application question, and it's this question right here. So what it reads is, the half-life of strontium 90 is 25 years. For a 160 milligram sample, how long would it take to decay to 10% of its original amount? So now what we want to do is we want to find out what our stuff is. So our N would be 125. Sorry, would be 25 because it's 25 years. So we put 25. And our PO would be 160 because it's a 160 milligram sample. And now, and since it's decays at 10%, so we put 0.10 times 160 equals 16. So our P is 16. Now, what's the formula? Formula is P equals PO 1 minus RN. Okay, so now let's just fill it in and let's solve this. 16 equals 160 0.5 T slash 25, and that'll be 16 over 160. 0.1 equals 0.5 T 125 T slash 25, my bad. Then we take T over 25 and we'll put log 0.1, and under that would be log 0.5, and now we put T over 25 equals 3.3, and then all we would do is take T equals, take the 25 times by 3.3, and our answer will be 82.5. And you can't just leave the question like this, you always want to leave a therefore statement. So therefore it will take P 25 years to decay to 10% of its original amount. 10% of its original. And it's pretty simple, and I think you can learn it very fast. So all we have to do is take -3. This is the question here that I'm writing. -2 plus 4 and 2 -3. So now, if it's negative, what you want to do is flip it and put a 1 on top and write it on the bottom, and then it'll turn into a positive. So it'll be 1 over -3 to the power of 2. This will stay negative because that's the main number. And we can put plus 1 over 4, and that the negative will be gone away to a positive. Now all we have to do is just solve it. We put 1 over 9 plus 1 over 64, and since we can't just times 9 into 64, all we have to do is just times this by 64 times 64 times 9 times 9, and we get 64 over 576 plus 9 over 576, and that will equal 73 over 576. Now this, you can leave it like this if you want. You can also turn it into a decimal like I did here, and it equals to 7.8. Okay, so that's one question. Now if we want to try another a little bit more complex question, let's flip to the next page, and let's try this right here. So m to the power of 4, n to the power of -3, brackets 2, m5, and -2. So now this will turn into m4 n2, and under it will be m5 n3, and under it we'll put, since it's the 2 right there, so it would turn into m8 n4, and under it will be m5 and n3. And now what you have to do is, since it's division, all you have to do is subtract. So m5, 6, 7, 8. So it'll be m3 and n1. So you don't have to write that. So it'll just be m3n, and that's it. So I hope you guys learned how to do 3.2, and now you guys know how to do exponential decay and connecting to negative exponents. Thanks for watching.